We're going to look at operations on functions. So we'll start with two functions, f of x equals x squared minus 3, and g of x equals x plus 2. The first operation will be addition. There's two ways that we can write it. We can either write it as f plus g of x, or we can separate it out into f of x plus g of x. You'll have to recognize both as meaning addition of our two functions. So to do this, we go ahead and write f of x, which is x squared minus 3, and then add g of x, which is x plus 2. And then we always simplify, so adding our like terms gives us the sum of x squared plus x minus 1. Next, we'll look at subtraction. So the first way to write it is f minus g of x, or, once again, we can separate it out into f of x minus g of x. You'll see when we put a number in here that it actually alters the order of operations. So we take f of x, which is x squared minus 3, and we subtract off all of g of x. So we have to make sure there's parentheses. So it's minus the parenthesis x plus 2. And then distributing that, we get x squared minus 3 minus x minus 2. And then adding our like terms just gives us x squared minus x minus 5. Next, multiplication. We can either write it as fg, which means f times g of x, or separating it out, it's f of x times g of x. So this time we'll have x squared plus 3 times x plus 2, which we'll have to FOIL out. We get x cubed plus 2x squared minus 3x minus 6, and we have no like terms. Finally, division can be written as f over g of x, or separating them out, it's f of x over g of x. So this gives us x squared minus 3 over x plus 2, which can't be simplified. Now let's look at an example. So we'll start with the function f of x equals x squared plus 7, and g of x equals x minus 2. So we're asked to find f plus g at 2. And I'm going to do this two different ways. I'm going to first of all do it in the notation that it's in. So to do that, my first step is to find f plus g at x, which is x squared plus 7 plus x minus 2. And then adding our like terms, we get x squared plus x plus 5. Now, I have to find f plus g, and then plug in 2. So we have f plus g, so it's now 2 squared plus 2 plus 5, which gives us 4 plus 2 plus 5, which is 11. So that's the first way to approach this, is to add the two functions first and then plug in 2. However, I can separate out the notation into f at 2 plus g at 2. So this means the first thing I'll find is just f at 2, which would be 2 squared plus 7, or 4 plus 7, which is 11. Then I'll find g at 2, which is 2 minus 2, or 0. So f at 2 plus g at 2 is 11 plus 0, or 11. So you can see we get the same answer either way.